Dear students, welcome to this video number 8 on simultaneous fault. In this video, we shall continue with our learning outcome number 4, that is simultaneous fault. And today we shall take a Y type of fault. It is also called as parallel connection. Now it is used to analyze the following type of faults. So two LLG fault at ith and jth bus. So in the suppose if I have a power system and I have a ith bus and jth bus, and here if LLG fault is taken place and at this jth bus also LLG fault is taken place, then we can analyze this simultaneous fault, that is called as Y type of fault. It is also called as parallel because in LLG we have seen that the sequence networks, they are connected in parallel, and so it is called as parallel connection also. Y type of fault, if there is a LLG fault at ith bus and one conductor fault at the jth bus, and for these two faults taken simultaneously, then it is also called as Y type of fault as parallel connection. Because LLG, we have seen that the networks are connected in parallel, and for one conductor fault also the networks, sequence networks, they are connected in parallel. Then we can analyze one conductor fault at ith bus and LLG fault at jth bus. It is vice versa. Then the fourth, if one conductor fault are taken place at ith and jth bus, so it is also called as Y type of fault, and it is called as parallel connection. So this is the same way we should write in the exam also. If they ask this Y type of fault, then we can write this. Next, now let us obtain the equations for analyzing in terms of Y parameters. Now why we are using Y parameters here, two port in terms of Y parameters, because now sequence networks, they are connected in parallel, and we have seen in the previous class that when the networks are connected in parallel, then we can combine the Y parameters, or we can get the Y parameters of the equivalent circuit using Y parameter terms. So now this is the network, it is shown here. Let us understand what this indicates. So this positive sequence network here, this indicates the two-port network of the positive sequence network, okay, with uh, with input port here. This input port represents one fault location and the output port represents the another fault location. Okay. Similarly, this negative sequence network, it represents the two-port network in terms of Y parameters. Here you have to be very specific. These two-port networks, they are defined with Y parameters, and here also the input port represents the fault at one location, uh, and the output port represents the uh, fault for another fault location. Similarly, zero sequence network, it is a two-port network of zero sequence passive network of the system seen from the two fault locations. Now, all these are connected in parallel through these transformers. These are isolation transformers. but here they are not functioning like a transformer. Uh, Here also we have isolation transformer on the output side also. These are these are not functioning like a transformer, but they are accommodated here to take care of uh, the uh, the line on which the fault is taken place. Okay. Uh, Now here we have equations. Let us understand the equations here. Now here it is the first equation is now find the positive sequence current. Okay, so at the fault point, suppose I take one case to understand this. I will take three lines so you can understand how the why isolation transformer is included. Suppose this is A phase, B phase and C phase, and now this is the location, we will call it as X location, and this is the location. Hello sir. ಹಾ ರೈಟ್ ರೈಟ್ ಸರ್ ನಾವು ವಿಡಿಯೋ ಮಾಡ್ಲಿಕ್ಕೆ ಫೋನ್ ಮಾಡ್ತೇನೆ ವಿಡಿಯೋ ಮಾಡತ್ತೇನೆ. This is Y location at another fault is taking place. Okay, that now both are LLG fault. Let us take example. Okay, now what we are interested here, we are interested in what is the fault current here, that is Ix, and here what is the fault current Iy at this point. Okay, now let us LLG fault, you can take it on, A, B and these two are grounded. Here also A, B, it is also grounded. So I am taking both same cases. Okay, now first we have to, now Ix, we have to get first what is its positive sequence component I1, then negative sequence and then zero sequence. So these are all at location X. Okay, so at the input, at the first fault point, that is at X, you can say we are getting these positive sequence currents. So II1, Ij1, this indicates the positive sequence current, uh, at the two fault locations at X and this is Y. Now what this vector indicates? This vector indicates the pre-fault currents. This indicate the pre-fault currents. Pre-fault currents at that faulted location. Now these two matrices together, this gives the change in the current. So what is due to fault at X and Y location? What is the change in the current? So here the approach, Thevenin approach is used to analyze the fault. Okay, now let us come to this second equation. So what this indicates? Now as I told, these transformers, they are as isolation transformer, they do not work as transformer here. It is just take care of the line on which the fault is taken place. Suppose uh, now if the fault is taken place on A and B at X location, then your Ni will be 1. Your Ni will be 1, indicating indicating that there is no need of any uh, transformation. Suppose if the fault is taken place B on C, then your Ni value will be alpha square. If the fault is taken place on C and A, then your Ni value will be alpha. What is alpha here? Alpha is the vector 1 at an angle 120. Okay. So similarly, there is a transformation ratio for the fault taken at yth location. Now, what you have to do, this equation, this equation, we have to substitute into this equation, then we get this entire equation. Just I will tell you one equation. Just I will give you one idea. Now here I will write the first equation. Say II. Now I am taking this equation. II equal to ISI minus YII VI minus Yij Vj. Now you see here. Now suppose if we assume that the fault, uh, now we have to take care of this, we have to take care of this transformation ratio. So now we have to multiply this entire equation by Ni, so that you can take care of the line on which the fault is taken place. So we have to multiply this entire equation by Ni. But what is Vi? This also we have to substitute. What is Vi? Vi in terms of this output, uh, sorry, this is uh, in terms of Vx, you can say it is Vx divided by Ni. So, and what is Vj? Vj is equal to Vy divided by Nj. So now this, it will be Vx divided by Ni, and here it will be Vj. This is Vi divided by Nj. So if you take this Ni into bracket, so you can see ISI, it will be multiplied by Ni. So here we get this term, and this YII, Ni, this Ni and this Ni will get cancelled. You will have Ni only over here, and then if you take this, for this term, if you take this Ni inside, so the Ni divided by Nj Yij, and here it is small change you make, please, Vx, and this is Vy, not okay. So this is how the equation is obtained. Now this equation, let it be 1. Now let us come to negative sequence current. Now this is the equation B, will give you the negative sequence current at the faulted locations X and Y. Okay. Now here we are not accommodating the pre-fault current, so the pre-fault current vector will not come into picture. Then equation C will give you the negative sequence current at the ith bus, at the X and Y location. Then let us come to this final equation. Now, as we know that, as I told, that the current at the fault Ix, it will be sum of the three currents, I1 plus I2 plus I0, that is sum of the three sequence currents. So Ix1 plus Ix2 plus Ix0. So that we are added, so we'll get the fault current at the X location. Similarly at Y location. Now if we add A, B, C, then we will get this final equation over here. Okay, now this addition I will not do, you please take care of yourself. Now after, ultimately you will get y11 as this, y11, it is like this, yij, it will be like this, and yji, it will be like this, and yjj, it will be like this. So now what we have done here, we have, what is this final equation? This final equation will give you the current at the faulted location X and Y. So uh, what you have to do, you have to calculate these parameters yi, and this is the equation. Okay, so first you have to calculate these y parameters, the equivalent of the equivalent network, where three two-port networks, positive, negative, and zero, they are connected in parallel, and then you have to multiply it with Vx and Vy. Okay, and then you can get this correction. Okay, so in this video, up to this only, we shall continue in the next video. Thank you.